And I'm recording again. I'm sorry, I just made some mistake somewhere.
Okay, that's good.
Just wait for 1 or 2 minutes because some people are going to rejoin.
Mm-hmm.
Some more people should be rejoining.
Oh, it is only for 30 minutes, eh?
No. I did not log in by mistake. I did not log in, so it was a basic meeting.
Oh, okay, okay, okay.
But I do have a license, so now I have.
I see.
If
Mm-hmm.
you log in with a license, it can be like as long as you want.
Mm-hmm.
Students, can you just ask others to rejoin quickly? Those who are there. Okay, Shudip, maybe you can start again.
Okay, so let's start.
Yeah, students.
So, so we discuss about the levy process, right? The definition of the levy process and how we can use the levy process for modeling the stock price. Now we are actually going to discuss about the pricing with the levy process. First, we discuss about the pricing rules. Okay, so in the market, if I have a stock price, say stock price with Dynamics AST. So say I have D assets, D number of assets, okay, and or amount of assets are like with a phi. So phi, I am calling it a strategy, okay, and then the value of my stock price is basically the summation of this, right? And obviously stock price will vary and it will change, and because of the change I will either incur loss or gain. So I'm defining the gain as integral of this, so I'm taking a ds, so change in, okay, change in stock price. Now the cost I'm defining a cost of this particular case, okay. The city is basically the value minus gain, that's basically cost. Okay, so here it is like a loss, I'm defining as a loss or the gain with the gain function, okay. And obviously initial value, I have this value of the stock. Now I'm defining a strategy called self-financing strategy. Self-financing strategy is basically this phi, okay. So I'm defining such a way that the cost of this strategy is zero, which means the value Vt is equal to basically the gain, equal to the value equal to the gain. Okay, so if the value equal to the gain, in that case the cost becomes zero. Here the cost becomes zero, and the Vt I can I can actually define like this. Okay, only this part remains. Now initially if I have a stock like in my, I have say five zero number of stocks with price say zero, and if it is changing like this over time, then I can also write like this. I can expand this bit. Now this is called the phi is called the self-financing strategy. Now another concept is called the arbitrage opportunity. Now arbitrage opportunity is nothing but a self-financing strategy with certain conditions. Okay, so it is the phi, basically it is the phi, okay, with certain condition. What are the condition? That I'm assuming this in arbitrage opportunity there is no actually there is no loss at all, okay. And I'm defining this way, the probability of initial and probability of value, okay, with the strategy phi is always greater than 0 is 1. So it is almost sure that always it will be positive, the value. Okay. And also if I have initial value V0, okay, and the terminal value should be always greater than initial value, because I'm starting with one particular value, I'll be expecting that, you know, final value would be always greater than, otherwise I will incur loss. Okay. And this, if this probability is not equal to 0, okay, then I'm calling it an arbitrage opportunity. So arbitrage opportunity exists means self-financing strategy exists in this particular case. Okay, now why I'm discussing about all this arbitrage opportunity? So I'm discussing about arbitrage opportunity because if such kind of arbitrage opportunity exists, it is possible that one particular contract may have multiple price. Okay, but in that particular case, the law of one price is violated. Okay. Second problem is that the same terminal payoff, okay, may have multiple values. Okay, multiple, you know, initial values for the same terminal payoff, and in that particular case, the hedging is not possible. So we'll be discussing in detail later on, but main idea is that if it's an arbitrage opportunity exists in the market, the pricing is not possible. There are issues with the pricing. Okay. Now, if I want to make it, if it is like, you know, if you want to compute the price of the contract, then I have to make it arbitrage free, that portfolio. The portfolio I'm considering here like this, okay, and the value of the portfolio is this PT, okay, and I have to make it arbitrage free. How can I do that? Let's consider a physical measure for the particular market is P. P is a physical measure of the market. And if I take the physical measure and try to compute, there is a possibility that there is an arbitrage opportunity that may exist. But let us take one step, that we will change the measure. Okay, we'll change the measure which is equivalent to the P. Okay, now here what I'm defining the measure, new measure as Q, which is equivalent to the P, and with that particular P, with that particular new measure Q, okay, I can derive this expectation for this terminal for this portfolio value VT. Okay, and you see this is coming to integral 0 to T phi T ds. Now this value will be 0 when this particular value is 0. Okay, under this particular measure Q, new measure Q, which is equivalent to P. Now this is a random variable, right? ds s is a random variable, so this is a random variable. This random variable may have both positive and negative. That's why this expectation is 0. Expectation is 0, that means it will have both the negative and positive values. So in that case, under this measure, we can certainly say that VT with that particular, you know, strategy phi is always greater than equal to 0. Is greater than equal to 0 is not equal to 1, because it is both negative and positive values are there. Certainly it is not 1. Okay, so in that particular case, if I change the measure, then there is a possibility that it will be arbitrage free and don't have any arbitrage strategy, and our pricing method will be a good one, and one unique price will be there. Okay, so so idea is that we have to change the measure. Okay, Now, under a new measure, okay, the stock price also has to be martingale under Q. Because see, if this is valid, then A has to be a martingale, right? Otherwise, it is not possible. So Q is a martingale measure that we need to find out to make it a arbitrage free and also getting the unique price of the contract. Okay. Now there is, and let's make Q a risk neutral. What is risk neutral? Okay, we'll be discussing about that. First, we'll be discussing about the linear pricing rule. So linear pricing rule says that they expect the expected payoff in the future. Okay, I'm sorry, expected pay. What will be the present payoff of the contract? Will be the discounting of the expected payoff of the future. So this is the future payoff. And what I'm doing is that I'm taking expectation and doing a discounting because this is the present value. Okay, so whenever this is valid, okay, and that particular Q, that martingale measure is called the risk neutral measure. So here I'm defining a measure, changing the measure. Okay, now again I'm forcing another condition like this, where the measure will be risk neutral. So this is also martingale measure, but holds this condition. Now question is that we are defining this way, that's fine, but is it really, I mean, is there any Q really exist? If it is that, how to find it? That's a one question. So I'll park it, this answer to this question for the time being. Okay, let us raise another question. In the market, is it possible that I may have multiple Qs? Okay, if there are multiple Q, then how to select a particular one? Because if there are multiple Q, the pricing will be multiple. Okay, so we'll be discussing in more advanced steps, but these are the questions probably been raised. Okay, up to this, any question?
No, sir.
No question? Okay, great. Okay, so let us discuss about the concept about the hedging portfolio with contracts. Now, initially I discussed that the contracts are required to hedge the loss. Hedge the loss means basically because of the changing in price, okay, we are incurring the loss. And the contracts are kind of an insurance contract, which is like if the loss is happening, then we can actually, and then in that particular scenario, the contract will give the payoff, and that payoff will compensate the loss. Okay, so let us consider one particular claim or contingent claim or for the particular contract is H. We are using to offset the loss. Now, because of the change in price of the stock, okay, we have this gain or loss. Okay, and if I'm considering only stock, I can considering the cash or bond also. Then total loss or gain is like this. So, and if I have the initial value of the portfolio V0, then total loss and gain is like the total value of the portfolio is this. Okay, now this should be equal to the payoff of the contract. In that case, I am always safe that, okay, if the loss is happening with my portfolio, then obviously I know that this contract value will be equal to the loss, and I will not incur any problem with my portfolio, right? So it is compensated with that particular contract, H. H means is the payoff for the contract, okay? And here, my self-financing strategy is phi T or phi T naught. T naught is for cash or bond. Okay. I've taken both stock and cash or bond. This particular case, we call this is perfectly hedged. So this is the value of this contract, value of this payoff of the contingent claim is equal to this, exactly equal to this. Okay, and if I can find any self-financing strategy, then I call this market is complete. This market is complete, and it is perfectly hedged. It is equal. Now, question is, does this really exist in all market? Okay, so that we need to investigate. Is it really possible to hold this equation? Okay, the second is, if this is holding true, okay, then why do I need contract? I will create a portfolio with these stocks and it will exactly offset the risk. I don't need any contract like this H. So, so in complete market, honestly speaking, the contracts or these contingent claims are basically redundant. It's not required. Okay, now what happens when this equation is not holding true? So there is no financial self-financing strategy that is giving you this particular condition. Okay. In that particular case, there will be a difference between these two. Okay, H minus and with all these values. And it is quite possible in many markets you will get the difference. Okay, and that market is called incomplete market. Okay, and the incomplete market, this way we cannot derive the hedging strategy. We can derive the self-financing strategy. Sorry, self-financing strategy. Okay, let's see what would be the approach for this particular scenario. Okay, when the market is incomplete. Okay, so in incomplete market, let's do one thing. Let's consider the hedging error. Okay, what is hedging error? I'm taking this is the contingent claim payoff, and this is my loss and gain and initial value. This is my portfolio value. So this I am taking as a hedging error. So in case of complete market, this error is 0 basically. But in incomplete market, it will not be 0. So what we should do? We should try to minimize this hedging error. Okay, and try to find out a strategy phi. Now, for this particular case, there are various approaches taken by various, researchers and scientists. Okay. Now, there are a couple of approaches I will be discussing here. So one approach is called is developed by Martin. It's called the Martin method, where Martin consider the hedging error as a discounted of the payoff and the portfolio value. So he's taking discounting and then trying to minimize the discounted error, basically hedging error. So this is hat is a discounted. Okay, and second approach taken by another set of researchers, which is called super hedging. The super hedging approach is that we look for phi, okay, the strategy phi, okay, such that the probability of VT phi, or the value of this portfolio, okay, which is basically V0 plus this loss and gain, which is always greater than H. And that probability is 1. In that case, if you find some phi, a strategy phi, then we call it a super hedging. So with the super hedging also, super hedging is also another approach for incomplete market. The third one is very interesting, which is called utility maximization, okay, where there is an investor, okay, with some investors utility function, okay, and investor has some initial investment amount of V0 is equal to say X. So obviously I will have, if I'm an investor, I will have some initial investment amount and I have some utility. Say I want to maximize something, okay, not always the profit, but maybe something else. Okay, so in that case, I can find out if arbitrage strategy, find out a strategy phi, okay, and so that the expectation of these particular value, okay, the loss and gain, initial value plus loss and gain is maximized. Okay, so this is actually, there's a typing mistake, it will be Q under certain measure P. So this is also another approach. The last approach is that which is called the quadratic or mean variance approach, where what I'm doing is that I'm taking the difference, the portfolio value minus my claim value, and I'm taking square of that, so absolute value of that, and this has to be minimum, right? So this is like a mean square, taking the error square. So this is like error and that square I'm taking and trying to find out the strategy phi. So even the market is incomplete, there are different ways by which actually you can find out the strategy phi, and also strategy phi for for pricing. So in that particular incomplete market, you have to find out Q, okay, that measure Q, that particular measure Q, okay, by these approaches, okay, and that you can use for pricing contracts. So that was all about. Now let's discuss. So let's, I mean, if we have some time there, we can, discuss about, we can answer questions.
Okay, Sudeep, so do you have some references? Because
these references I have actually, I will share later on.
okay, so I'll
yeah, so initial, actually I pasted into another slide. Okay. So I'll share it later on. Is it okay? Or
yeah,
shall I open it?
Maybe you can show them one or two of the main ones, because Content, Tenkov and others.
Okay, okay. That's fine.
Just point out the principal ones.
Okay. Okay, so some of the interesting references I should tell you about the pricing and hedging in incomplete market and pricing with the Levy process, which are okay. Okay, so first of all, you can read this book called Pricing. Read this book by Ramakant and Tankov, Peter Tankov. Name of the book is called Financial Modeling with the JAM Process. This is a very interesting book. Okay, for the Levy process and option pricing. Now for okay. This is also another interesting paper by T. Chan, where the contingent claim pricing, okay, they described here in this particular paper. Okay, then one very interesting paper by Fulmer and Schweizer. They describe that different hedging strategy in incomplete market. So this is the paper. If you want to, work on the in the area of incomplete market pricing in the incomplete market. So this is the paper probably you can follow. Mhm. Okay, so apart from this, okay, this is also another interesting paper by Capriano and Schoutens, exotic pricing and advanced levy models. So these are all main papers where actually you will get a lot of stuff in pricing with the levy process and also pricing and hedging with the incomplete market. But for hedging, I think these are the two papers, Fullmarch-Weiser and Ramakant, book on the Ramakant. So this is like Fullmarch-Weiser, this paper, and
All right. So, are there any questions? Any clarifications from the students? Okay. I guess there. Yes, Akash.
Akash, any question?
No, so
No, sir. No.
yeah.
No question?
No, sir.
You're getting interest in the subject.
Yes, sir.
Okay. So which part do you think is best or most interesting to work on?
Well, the stochastic process, obviously, like I still have to, go through a lot of it, but
Okay.
yeah. So how
But
the
main
levy
idea you
process?
got it right. Main idea
Yes.
is pricing and hedging.
Yes, sir.
So pricing is like, uh, first finding out the risk neutral density.
Right.
And the second, that will be very challenging, very interesting. And the second part is obviously pricing expression. And third one is
The
the
modeling.
hedging strategy.
Yes.
So with this book, I'm keeping these particular, these three areas. You can study actually this book. And you can take my presentation as a reference and you can actually refer, you can go to different books and find out the content, and in detail, probably you will get answer for this. But try to get answer for the question that I raised, like how many martingale measures are there in the market? Okay. Is there any strategy exist or not? Okay. So all this kind of question, if you get the answer either from internet literature or from the books, then you will get interest actually.
Okay.
Got it?
Yes, sir.
Okay.
Okay. So, thank you, Shudip. And
Thank you so much, Professor Mukherjee, for giving me such an opportunity to present the idea about how to price in the incomplete market with the levy process.